Good day. I'm Nicholas Dunius, Managing Director at Altus Biologics Pty Limited, a small startup company that was founded in 2003 with a mission of commercializing novel bone regeneration technologies. Today, we will take a quick tour of our company. Right now, we find ourselves in the Research and Development Laboratory and the Quality Control Laboratory together with my two colleagues. We have scientists, graduates, and students at the company, and we do very exciting work to bring into the market the bone graft technology that was invented more than 2 decades ago. So, what made us come to the Innovation Hub? Well, we consider ourselves a spin-out company from an institution, a university. During my PhD studies, a number of discoveries were made which led me to think that this can really be of great assistance in the field of orthopedic surgery, where we are able to treat large bony defects, large bone voids, using a new method. The method of bone induction using novel growth factors and mixtures of growth factors that interact synergistically to bring about the phenomenon of bone induction. So that is the technology that we decided to commercialize. How to commercialize? Well, we use the triple helix model of Escovitz. It is a very well-known model of the interaction between three main players in technology entrepreneurship. That would be institutions like universities and scientific councils, the entrepreneur himself in the startup company, and of course government and government funding. So we were very fortunate to raise government funding. The Innovation Fund was awarded to us in 2004, and we started a long pipeline of commercializing this technology, of developing the technology to multiple phases of preclinical studies, human clinical studies, and of course the regulatory process to bring it into the marketplace. Initially, we established ourselves at a University of Technology, where the cooperation was very, very good. It was very, very appropriate. At the time, we were a startup company that was able to interact with the university in a way that was beneficial to both parties. A number of theses were produced at the university to support the technology, to support the product, and to support the preclinical and clinical studies. And at that time, we realized after the 7 years we complete of the research and development phase, it was time to choose a technology park where we could be incubated as a little fledgling startup to be able to sprout a new organization, as it were, to be able to hatch a new development that would bring this exciting technology to the market. And we chose the Innovation Hub for multiple reasons. The Innovation Hub, located in Percy Court in Pretoria, is a technology park that has many buildings available to different levels of startup organizations, from single-man startups all the way up to 20, 30-man teams. I should say man and woman, of course. So we decided to establish ourselves at the Enterprise building initially, where we were able to build our laboratories and to hire a new talent locally from South Africa and to initiate new projects to start the commercialization phase. And the first stage, of course, was to certify the laboratories to international standards, to produce prototype products, and to be able to demonstrate to the surgeons that this product is safe and effective to use in clinical settings. This interaction with the Innovation Hub was very, very successful. We were able to commercialize a product in 2012, and we launched the product into the marketplace, and soon it became a leading product, the first and only injectable bone morphogenetic product at the time in the marketplace to go into the mainstream clinical settings. Soon thereafter, we were able to raise more funding, government funding, We were able to collaborate further with institutions like universities, science councils, and to continue to develop and grow our portfolio of products so that we could offer a more complementary suite of surgical products that could heal the defects. And these products expanded further. For example, we were able to develop at the Innovation Hub new products such as fibrillar collagenous membranes. These membranes are important to segregate tissues in a clinical environment to make sure that soft tissues do not impinge upon the regeneration of the bone. As an example, we were able also to develop ceramicized products, ceramics, sintered spongiosa bone products. And these products had a great, or still have a great utility in being able to reside longer in the bone void and to promote osteoconduction so that the bone can be united, can be healed over a longer period of time. We were also able to develop one of the very first certified load-bearing bone graft substitutes from animals, from the pig, as we typically source the material. And this new bone graft is exciting because it is tested in a laboratory to be weight-bearing to a certain number of kilograms so that the patient can benefit from the implant in a way that it can stabilize and be load-bearing immediately upon implantation. There's of course future research that we will continue to conduct at Altus Biologics. We will start combining novel growth factors and growth factor fractions that we purify naturally. Also new growth factors that we intend to manufacture through recombinant DNA technology. We have a program where we are designing novel cocktails of growth factors which we hope will synergize in a clinical setting and be able to deliver to the patient rapid, safe, and effective bone formation. And in future, we will start combining this new cocktail of growth factors with this new scaffolds that we have developed, and we hope to be able to go into the future with more developmental pipelines of these exciting bone grafts at the Innovation Hub, at the Biopark, and to continue to expand our facilities. What you see around us today, as I said, is the laboratory section where we do the quality control and some of the research and development, and we will take you for a tour of the internal structures of the clean rooms where all the exciting bioprocessing happens. Right, let's start. So right now we find ourselves in the heart of the bioprocessing laboratories, the clean rooms at Altus Biologics, located in a 600 square meter total facility of clean rooms and laboratory space. The bioprocessing of bone grafts is really a very interesting topic. We start, of course, with mammalian bone tissue. It can be porcine, pig, can be bovine, like a cow. And we have a patented technology whereby we are able to humanize these tissues, the bone tissue. We are able to, as it were, disassemble the bone tissue into fractions, and then we are able to isolate important fractions like the collagen scaffold, the growth factors, the bone morphogenetic proteins, and then purify them to a high degree so that once we recombine them into the finished product, we have a high degree of biocompatibility in the human. So today what we see around us is, for example, the ultrafiltration processing on that side. Behind me in the other laboratory we have a lot of the chromatography equipment where the purification through multiple chromatography steps takes place. Here we have a liquids handling system, and altogether these laboratories are able to produce the highest level of bone graft substitutes that can be used in human medicine. Right, so right now we find ourselves in the heart of the bioprocessing facility at Altus Biologics, located at the Biopark of the Innovation Hub. This is the heart of where the most important bioprocessing of bone morphogenetic protein takes place. we purify a cocktail of morphogens, as they are called, which are very important in the final assembly of an injectable bone graft substitute device, which is able to induce new bone formation and bring about the regeneration of bone defects. These defects include conditions and defects in the spine, in the cranial and maxillofacial skeleton, in the appendicular and axial skeleton, and of course in the periodontal region, which is very important in the anchoring of our teeth. So what we see in this laboratory are a number of stations, which include the chromatography stations, where the morphogens are processed from a crude extract through multiple chromatography steps to obtain a final purified morphogen cocktail, which is biocompatible to use into humans.